So just a quick wee video here, guys, bringing out the Handtech 1008. Wow, it's a blast for the past, eh? The reason I'm using the 1008 is it's got really good measurement function, and I like the way it clearly displays. It's good for video purposes, the measurements. So what I want to point out here is if you have a driver which is driving a load and it's pulse width modulated or duty cycle controlled, like this rig is, guys, this little test rig. In this case, it's driving a DC motor, a brushed DC motor. Well, anytime you have a magnetic field that's cutting across a coil, like the motor is obviously set up, you'll also meet the requirements for generation, right? So this will actually generate a back EMF into the system, and I'll show you that on the trace momentarily here. I've showed you this in a video before, but I want to focus on a wee bit more that aspect of the previous video for a simple reason that this could really make a mess of your diagnosis if you're trying to suss out an issue with a circuit that's duty cycle controlled. So I'm just going to, it's 1000 hertz, 1.0 kilohertz, and here's my duty cycle, guys, right? So you can see I've got the frequency on there. Those are meaningless at the moment, but once we actually start, I'm just going to get the motor to just start rotating. There we go. 8% duty cycle, positive duty cycle I'm talking about here, guys, right? That's why it says positive duty cycle on here. It makes a big difference. And the supply is 12 volts, by the way, okay? So you can see there that the maximum voltage is 12 volts. That makes sense. And the frequency is pretty close, 1.0 and change kilohertz. All makes good sense, right? That average doesn't look right, though, eh? Those that are quick with mathematics will realize that 8% of 12 volts is not nearly 2 volts, right? Not even close. So the point to the video again, guys, the induction of this EMF is going to start to skew these values. Right now it's not too bad, and the brains within the 1008 can cope with this degree of bastardization in the trace, but not for much longer. Watch, I'll step it up to let's go a 20%. Look at the duty cycle. It's a mess. It's all over the place, because you can see here, because of the induction of the EMF, the back EMF on the trace, it's buggerizing everything, right? Look at the maximum voltage. Because of the induction, you can see there's some spikes there. It's being skewed. And now, in spite of the fact we're still driving this with 1000 hertz, the frequency is out to lunch. And 20% of 12 volts is not 6.5 volts, but it is as far as the trace is concerned. This calculation is all coming from the trace, not from the drive. The trace is being bastardized because of the back EMF. Let me turn this up so you can hear what I'm talking about, right? So, just to prove the point, let me show you a non-induction a load that's not going to induce a back EMF, and we'll see the difference. Okay, so just a simple little lamp here, guys, is our load. This has to have a load on it, by the way. This little test setup I have here has to have a load. Otherwise, if you look at the open circuit trace, it's a mess. It needs to have a load. So right now, let's put the drive on, which is on, but is 0% duty cycle. So you can see here, all the parameters really make some sense, right? So let me just go to 1%. Let me go to 10% so we can see something sensible here. You can see all the parameters make sense. You can see how clean that is. And of course, we just have the tiniest glow on the lamp load. Let me step it up. Let me just stop 33% here, because I don't know, why not? It looks good on screen, right? You can see with the clean trace, everything looks sensible, right? 33%, I'm no math genius, but 33% of 12 volts, 4 volts makes sense. Frequency looks right, maximum voltage looks right, duty cycle looks right. Again, there's our settings, right? 1000 hertz at 33% duty cycle, positive duty cycle. Be aware. Inductive loads, especially ones that can generate a back EMF, like motors, can make a mess of your measurements when it comes to duty cycle. That's control. A very long-winded way of saying, before you condemn the drive on a duty cycle controlled or pulse width modulated circuit, before you condemn the drive, make sure this kind of thing is not going on. Like there's a bastardization of the trace from a back EMF. If in doubt, just put on a suitable test light, you know, ideally one that's close to the current draw, nominal current draw of the load itself, and recheck the trace. Maybe it's not the drive. Don't be quick to condemn it. Maybe there's something else at play. That's it, boys. Cheers.